So, what is an inelastic collision? So, inelastic collisions conserve momentum, but not kinetic energy. Now, I know what you're saying to yourself. You're saying, Mr. B, you just literally said energy can't be created or destroyed. Total energy cannot change. And you're like, Mr. B, you just said that it doesn't conserve kinetic energy. Okay, it's fine to not conserve kinetic energy. It still conserves energy, just not kinetic energy. Okay? So that's what an inelastic collision. A totally inelastic collision is when they, so it conserves, basically it's an inelastic collision where the objects stick together. So if the objects stick together, it's called totally inelastic. Which means it definitely doesn't conserve kinetic energy. If it's just a regular inelastic, it might partially conserve kinetic energy, which means they're close but not the same, but they're close. If it's a totally inelastic, the initial kinetic and the final kinetic are usually nowhere close. So what's an elastic collision? An elastic collision is where it conserves momentum and kinetic energy. All right, so let's look at these real quick. I just want to show you what we need. Two equations to solve this. And the first one we need is conservation momentum. So momentum of 1 initial plus momentum of 2 initial equals momentum of 1 final plus momentum of 2 final. But because elastic collisions conserve momentum and kinetic energy, we actually need conservation of kinetic energy also, which is the kinetic energy of 1 initial plus the kinetic energy of 1 final equals the kinetic energy of 1, this is 2 initial, that's my bad. This is 1 final and 2 final. Okay, so we conserve momentum. Momentum total before equals momentum total after. Kinetic total before equals kinetic total after. So if this has a kinetic of 100 joules and this has a kinetic of 0, then after the collision, this will have a kinetic of 100 and this will have a kinetic of 0. The velocities will transfer exactly equally if the masses are the same. If the masses aren't the same, then the velocities won't change exactly equally, but they'll be proportional to each other. Okay? Okay. All right. It's time for